Okay, so we are sketching this. Let me get a graph. Okay, so the first thing we want to realize is which one is this? Is this the parabola, the V, or the shooting star? This is a parabola. Guys, I can't have the side talk while I'm teaching. Don't be rude. So then y is going to equal a times the quantity of x minus h squared plus k. So if I were to rewrite this, to write it in that a times the quantity squared plus k, this would be the negation of x plus 0 squared, or x minus 0 squared, doesn't really matter, plus 1. All right, do you all agree? I didn't really change the value. I just rewrote the same thing in a different way. All right, so we know our parent function, or our parent graph, looks something like this, right? With the vertex at 0, 0, and we're smiling up. But this A is negative. Because the A is negative, we're no longer going to smile. Now we're going to frown. We're going to open down. And now we're going to open down. Is our vertex going to shift at all? Yes. How are we going to shift? So it's 0 left or right because our H is 0. So H is 0. A is negative. And our K is positive 1. So we are starting at 0, 0. We're not shifting left or right at all, but I am going to shift 1 up. We're going to shift 1 up. What else do you think I'm going to ask you to find? So we did find our y-intercept right there. Our y-intercept is the point 0, 1. What else do you think I'm going to ask you to find? The x-intercept. So the x-intercept, we're going to plug in 0 for y. I'm going to subtract that that 1 over. Negative 1 equals negative x squared. I'm going to now divide by negative 1. So x squared equals 1. What does x equal? Plus minus 1. Am I going too fast? We're all good? Okay. So now we have negative 1 and positive 1, and we said we are frowning. So there's our graph. All right, so now I want to talk about domain and range. All right, remember our domain is our x values. Furthest left we go, furthest right we go. So furthest left, what does that look like? An arrow, which is negative infinity. Furthest right, also an arrow, which is positive infinity. So our domain is negative infinity, comma, positive infinity. Now our range. All right, well, the lowest point we go, aren't they here, the arrows, both pointing down forever? But the highest point is not an arrow. What's the highest point? Positive 1. So what are we going to say? We are negative infinity all the way to positive 1. Included, exactly. If we were going to do this in set notation, what can we write? We can say y such that y is less than or equal to 1. Do you need to know both notations for the test when it comes? Yes. So remember, I told you the first day of this lesson, that H represents the horizontal shift, K represents the vertical shift, and H will represent the horizontal shift as long as the coefficient of X is 1. What happens when the coefficient of X is not 1? Let me show you. All right, so I can't say I'm shifting -1. I can't say I'm shifting -1 because now the coefficient of x is not 1. So this changes things. This changes things. So in this scenario, I still know this is a parabola. Do we all agree? This is still going to be a parabola. But now let's figure out our x and y intercepts. So x-intercept, we're going to let 0 equal y. We're going to square root both sides. Square root of 0 is still just 0. So then we're 2x plus 1. Subtract the 1. -1 equals 2x. So what does x equal? -1/2. So there is my x-intercept. Right, so now let's pick the y-intercept. Let's find our y-intercept. So we're going to have y is equal to 2 times 0 plus 1 squared. So y is equal to 1 squared, so y is positive 1. All right, so what does this tell us? Are we going to smile or are we going to frown? Smile. Why smile and not frown? Because the a is positive. So this is just like that. Oops, sorry. I messed this up. What does that mean for that -1/2? What is that considered? No. Double root. Who said it? Matt, was that you? Good job, Matt. That is a double root. Right. This looks like a V. It shouldn't look like a V. And there we are. All right, so things change when there's a number in front of that x. You're going to then start off with the intercepts. Yes?
Wait, why is it a double root?
Because it's not hitting the x-axis again. So that means it hit it and bounced back up. Remember, that was the double root when it counts twice. All right, so now let's talk about non-standard graphs. So things are going to get a little bit more complicated here, and the domain is going to be our starting point when things get a little bit more complicated. We're sketching still. Okay. Do we agree this is some variation of the shooting star? Yeah, this is some variation of the shooting star. Can we use that Shift H up, left, right, Shift H, left, right, Shift K, up, down? No, this is not in that format. All right, so where are we going to start here? When we're dealing with non-standard graphs, we're going to start with the domain. Why am I starting with the domain? I know I'm restricted. I know it can't be all real numbers. How do I know it can't be all real numbers?
Because there can be a negative in the radical.
Good, because we can't have a negative inside the radical. So what are we going to do? We're going to take that radicand, that x squared plus 3x minus 4, and what do we need? We need it to be greater than or equal to 0. Can I have a 0 under the radical? Absolutely. So what have I now done here? I've created a quadratic inequality. What must we do when we have a quadratic inequality? Good. You have been seeing this since September. You all should know this by now. When you have a quadratic inequality, you must test the regions. All right, so how do we test the regions? Well, first we factor to get our reference points. So we're going to have x plus 4, x minus 1, greater than or equal to 0. What are my two reference points? Negative 4 and positive 1. So now we test. I'm going to test x is less than or equal to negative 4. Negative 4 is less than or equal to x, which is less than or equal to 1. And x is greater than or equal to 1. Now remember, we want it greater than or equal to 0. So do we want our products to be positive or negative? Positive. Since we're greater than or equal to 0, we need our products to be positive. All right, so I'm going to take a number that's less than negative 4. What's less than negative 4? Negative 5. So we are negative 5 plus 4. Isn't that a negative? And then negative 5 minus 1, isn't that another negative? A negative times a negative is a positive. If the left side works, what else is going to work? The right side will work, and what will happen to the middle? Okay, we'll cancel out. So what is this? I'm doing all this to find what? Not the zeros, no. What do you mean the x values? What is a word for possible x values? Who said it? Matt again? Look, Matt's on a roll. All right, we are doing this to find the domain of our graph, to find where the x values lie in our graph. So our domain we're going to have x such that x is less than or equal to negative 4, or, because they're not connected, right? The left side worked, the left side worked, the right side worked. So that's why it's an or x is greater than or equal to 1. So what does this mean? We're to the left of negative 4, and we are to the right of positive 1 on the x-axis. Do we agree? That's where our graph's going to be. What about that whole middle region between negative 4 and 1? Will there be any graph there? There will be no graph there because it's not in my domain. So it's to the left of negative 4, to the right of positive 1. All right, that's huge. What do you think I'm going to tell you to find next? No. There's no finding the range without the graph. Yes. The intercepts. I'm trying to visualize what this graph looks like. Let's get our intercepts. So I'm going to start off with the x-intercept. So the x-intercept is 0 equals the root of x squared plus 3x minus 4. Square both sides. 0 equals x squared plus 3x minus 4. So we are x plus 4, x minus 1 equals 0. X equals negative 4, x equals positive 1. Those are x-intercepts. Should there be a y-intercept? Should there be a y-intercept?
No.
Good. How do you know there should not be a y-intercept? Ryan. Exactly. The domain does not include 0, meaning we're not ever hitting that y-axis. Let's just see. What do you mean, wait?
Just two separate lines?
No, you start from somewhere.
We're getting there. We're getting there. All right. So now let's see the y-intercept. Just say, I like how Ryan was thinking. If I were Ryan, I'd be like, there's no point in even doing the y-intercept because I know there won't be one. Let's say you like to be robotic and you just want to computate things. Fine. You're going to get y is equal to the root of 0 squared plus 3 times 0 minus 4. Y will equal the root of negative 4. What do we realize? Imaginary. So no y-intercept there. Are we ready to see what this graph will look like? Dylan, are you ready? I know you feel the anticipation right now. Okay, so where do you think I'm starting off plotting? the x-intercepts. We're going to start off by plotting the x-intercepts. So we're at 1 and 2, 3, 4. Do we agree we have shooting stars? Yeah, because of the square root, we know we have shooting stars. All right, but now the domain is going to lead us. What does the domain tell us? The domain tells us I'm going to be greater than 1. So shooting star going greater than 1. The domain is also telling us I'm going to be less than -4. So what does that mean? Shooting star going the other way. And this is what our graph looks like.
Oh, we don't need to find the extra point.
Wait, so why is it
No extra points.
Why is it not 2 equations?
I'm sorry?
Why is it not 2 equations? Why is it just 1? Just 2.
Well, because the domain tells us it's going to be 2 lines. Because of the square root, we know we can't have a negative under the radical. So we're thinking what x values will create a negative underneath this radical? We can't touch those. So the domain is creating those 2 separate scenarios where this holds true. Does that make sense? All right, are we ready for another one? How about you guys try this one on your own? Y equals the root of x squared minus 16. Oh, I skipped some problems I should have done before.
We still understand it.
I'll do them after this problem.
That's good.
Would the 2 shooting stars always be facing outward?
Now I'm going to show you a scenario where it's not.
But then wouldn't it like
Yeah, wouldn't
pass
it
the
come
vertical
that
line
way?
test?
So it won't be a function. Oh wait, no.
So it's not.
It will still be a function because of the restricted domain. It will still work. I'll show you one.
For the 9 tenths.
Dylan, focus.
Sorry.
Dylan, I feel like you'd be best suited sitting next to Navia.
That'll be good.
She'll keep you in line. She won't talk to
Yeah,
you.
we help him.
But you really don't help him. You distract him more than
No,
anything.
I wouldn't be like, I would be failing.
So like Matt is immune to you guys. He can just put his head down and do his work. But you all, the rest of you, all just distraction. Kenny sometimes wavers. It depends on the day. But Chris is focused on the calculus that he's teaching himself right now. Are we ready? No? Are you guys lost? Who feels lost?
No, I just need I got it. I just need
You got it?
I got the same thing.
It's not the same thing.
No, I got the same thing.
Oh, as it, okay. I thought you meant as the problem before. Good. All right, let's go over this. So, again, is this a shifting scenario? Is this a shifting scenario where we shift left, right, H, we shift up, down, K? No, all right, it's more complicated underneath the radical. Do we agree, though, that it's shooting stars? Yes. All right, so what do we start? When it's a complicated scenario, when it's not just basic shifting, where do we start with? The domain. When it's a complicated scenario, we start with the domain. So what is the domain here? We know we need the radicand to be greater than or equal to 0. So now we factor. Because it's a quadratic inequality, not Arish, what are we going to do?
Test the region.
Test the regions.
Why is it greater than 0? Like, why would it?
Because there can't be negative roots.
Oh.
Because our radicand has to be positive.
Yeah.
Wait, so if it's under a square root, it has to be positive. It can't be negative.
Because what happens when it's a negative number underneath the radical? It's imaginary, so we have to be positive.
Wait, why can't we have imaginary?
Oh my God, Dylan.
Do you know how to graph imaginary?
Oh yeah, you do the eye. Different like that.
It's a different graph.
Different plane of existence.
Yeah, you're like in a completely different plane. Okay. So we are x plus 4, x minus 4 greater than or equal to 0. What are reference numbers? Negative 4 and positive 4. Okay, so now we test the regions. When we test the regions, do we want it to be positive or negative?
Positive.
Because it's greater than, we need it to be positive. So what regions am I testing? I'm going to test x is less than or equal to negative 4. Negative 4 is less than or equal to x, which is less than or equal to 4. And x is greater than or equal to 4. All right, I'm going to test negative 5. Negative 5 plus 4 is negative. Negative 5 minus 4 is negative. A negative times a negative is a positive. So this works. What else is going to work? The last column. What about the middle? It won't work. All right, what should we find now? This is the domain. Sorry, I got to write it out. You're right. Domain. X such that x is less than or equal to negative 4. What word should I put? Or. X is greater than or equal to 4. Why is it not an and? David? Because they're going in opposite directions. If it was an and, that means we want the numbers between negative 4 and positive 4. And is the middle one, exactly. Well, in the middle one, you read it as an and. Negative 4 is less than or equal to x, and x is less than or equal to 4. So you just write it all together like that. Okay, let's keep going. Where now that I have my domain, what am I going to, Dylan, what am I going to tell you to find now? The x-intercept, the x-intercept. Do we already know what the x-intercept is? Yeah, because we already factored and solved, didn't we? But let's say you didn't know. You're just going to plug in 0 for x squared minus 16. Square both sides. 0 equals x squared minus 16. X equals plus or minus 4. Is there going to be a y-intercept here? Aditya?
No, because x equals 0 is not in the domain.
Good. No, because x equals 0 is not in the domain. So what are we going to get? We have our x-intercepts 1, 2, 3, 4. 1, 2, 3, 4. And what's going to decide how my shooting stars are going? What's going to decide? The domain. Excellent. So my domain is saying we're greater than 4 and we're less than negative 4.
So in these problems, the range is like this.
Yeah. No. The range, and we're going to see one of those right now. You're not always going in opposite directions. You can come together, and I'm going to show you one of those right now. Yes, Claire?
Like, what's the scenario that, like, whenever you choose between the number and 0? I forget, like.
When it's between a number and 0?
Yeah, like.
You mean the middle scenario?
Yeah.
I'm going to show you right now. Okay, so let's say I want us to sketch y equals the root of 9 minus x squared. Do we all agree we have shooting stars?
Yeah.
Yes. Is this a classic shift HK? No, this is a special scenario. When we have a special scenario, what should I start with? Domain. So what are we going to do? We're going to take our radicand, and we know our radicand must be greater than or equal to 0. So now when I factor this is going to be 3 plus x, and 3 minus x is greater than or equal to 0. So my reference numbers are negative 3 and positive 3. All right, stay with me here. So I'm going to test x is less than or equal to -3. -3 is less than or equal to x, which is less than or equal to 3. And x is greater than or equal to 3. Can I choose -4? Yes. So when we have 3 plus -4, what is that? A negative. When I have 3 minus -4, what's that? Positive. So now I have a negative times a positive, which is a negative. So what happens? This region doesn't work, which means what else is not going to work? The last column will not work. What will work? Should I still test it to make sure it works? Yes, we still need to test it to make sure it works. So now we're going to have, can I choose 0 for this? Yes. So I'm going to have 3 plus 0 is positive. 3 minus 0 is positive. A positive times a positive is a positive. We have our winner. Yes, Dravid.
Is there a case that none of the three would work?
No, one of them will always work what I give you. Okay, so now, what is our domain here? Dylan.
X such that -3 is less than or equal to x, which is greater than or equal to 3.
Less than or equal to 3.
Or less than or equal.
All right, so do we all agree we have shooting stars, right? Now, our shooting stars, are they going away from each other? Or are they going towards each other? They're going towards each other. How do I know they're going towards each other? Because of the domain. The domain is telling me they're going towards each other. All right, what should I find now? We need to find the x-intercepts. So let's go ahead and find the x-intercepts. 0 equals the root of 9 minus x squared. So we have 0 equals 9 minus x squared. What do we end up getting? X equals plus or minus 3. Is there going to be a y-intercept? Should I find it? Yes. David?
I have a question. Could you just like use -3 instead of having to go back?
Yes. Yep, I had said that before. You should be able to recognize that, but if you don't, this is what you do. Okay, so now I'm finding the y-intercept. So now the y-intercept is going to be y equals the root of 9 minus 0 squared. So y is going to equal plus or minus 3, but it can't be a minus 3. Why? Good. All right, this can't be a minus 3 because we're saying y equals the square root of this. When we take the square root of a number, is it ever negative? No, there's no square. Like if I take square root of 5, it's never going to end up being a negative underneath of that. So that's not going to work. We don't want that. We're going to reject it. The answer is just 3. So now, let's go through and graph this. Okay, so look. So now we're going to get my x-intercepts, 1, 2, 3, 1, 2, 3, and then 1, 2, 3. Now, what you guys might be thinking is, I'm going this way, and I'm going this way, but it's not. Why? Because my domain is starting at -3, and where is it ending? At +3. So are we drawing those arrows that are passing those? No. So all we have is this. That is it.
So it's like a V.
It's half a circle. It's
No,
a
no
half
V.
circle. It's like a half circle.
Yeah.
We said it was a loop.
Looks like a loop. It looks like a loop.
I need to show you more things. Okay, so let's talk about why it can't be -3. Okay, I'll explain to it more in a graphing sense. Can we do that? All right, our number in front of this was positive, right? So the shooting stars, what do we know? The shooting stars were going up. So we knew we were at -3. We knew we were at -3 and +3, but we also knew they were going up. So then y would have to, if it was y was -3, they'd have to be going down, and that doesn't follow the rules of the shooting stars. Does that make more sense at like a graphing sense? Yes.
Can a shooting star go under the x-axis?
Yes, the shooting star can go under the x-axis if it's negative. Let me show you one, okay?
Just a couple of marks.
Yes.
On the test, when we go from testing the ranges straight to graphing, we could use the rest of the math.
Testing the regions, yes, absolutely. But I would need you to find the y-intercept if there is one. Okay, so let's do this. Is this a shifting scenario? Is this a shifting scenario? Why not? Yeah, this is a shifting scenario because it's y equals a times the root of x minus h plus k. Does that look like the same format? Yeah, it is a shifting scenario. So my a is negative. So what does that mean? Is it shooting up or is it shooting down? Shooting down. What's my h? 2, +2. My h is +2. Where did it go? Something just disappeared. Okay, my h is +2. What's my k? 0.
Was it not shifting from last time because it's square?
Because it wasn't written in this format. So the other one was, we had a quadratic underneath the radical, right?
So
It was an x squared, and yeah, like just if it's an x squared or if there's a number in front of x, it's then not fitting this scenario. Unless it looks exactly like this, then it's not that scenario. If there's two things being multiplied underneath of it, then it's not that scenario. All right, so we, the A tells us we're not shooting up, we're going to be shooting down. So our parent graph looks like this, right? But we're shifting that starting point. Where are we shifting that starting point? 2 units to the right. And instead of going up, what am I going to do? Go down. I didn't shift up or down at all. Why didn't I shift up or down at all? Because k was 0. But let's say I had k is 2. What would we do then? Go up 2 and then go down. Any point in trying to find the y-intercept here? There's no point in finding the y-intercept. Do we know the x-intercept? Yes. What would be the domain here? What would be the domain here? Matt? Good. So we would need x is greater than or equal to 2. What would be the range here? 0. Less than or equal to 0. The range is y is less than or equal to 0. Because it starts at 0 and goes down, yeah?
If k was 2, you have to find the x.
Yes. If k was 2, then you would be asked to find the x-intercept. Okay. I have more I want to show you. Let's complicate things a little bit. Are we ready for this? So, biggest mistake here. Do y'all want to know the biggest mistake? Biggest mistake is people think this is a V. Rach, say it again.
It's because X was squared.
Good. This is not a V because X is squared. So what is this? What's going on here? This is if this is not a V, because you see the absolute value lines, you want to think of V. So this is a parabola, but then what are they saying? We want the absolute value of this parabola. So essentially saying, I don't want y to be anything less than 0. Does that make sense? They're saying the absolute value, y equals the absolute value of this. So all the y's have to be positive. So this parabola has to be all in the positive section. So what are we going to do here? We're going to go through a couple of steps. The first step we're going to do is sketch y equals x squared minus 1. Is this shifting format? Why no? Y'all want to keep saying no. Is it shifting format? Yeah, why? Because I can write this as x minus 0 squared minus 1. What's wrong, Dravid? Why are you making those mad eyes?
I'm just. Well, yeah, I know.
It's okay, just ask.
No, it's because like the last one, like all of the other ones that weren't shifting had an exponent, like was raised. You know, it was x squared, and then when it wasn't x squared, it became the h and the k thing. But now it's x squared again.
I see what you're saying. Okay. So if I were to say y equals x squared plus 5x plus 6, okay? It's x squared, but is this in that format? Can I manipulate this to look like x minus h squared plus k? At the moment, right now, if we complete the square maybe, but like this is not your typical scenario, okay? So you have to look at each thing individually. So the shooting star is y equals the root of x minus h plus k. Nothing squared in it, right? So if we're now squaring something underneath that shooting star, now we're non-standard graph. Now we're not about shifting. But a parabola is squared. Y equals x minus h squared plus k. So if we're squaring for a parabola, is that okay? Yeah, so this is your standard shifting. Do you understand?
Yeah.
So you have to take it case by case. A shooting star standard is different than a parabola standard, which is different from a V standard. So in this scenario, when we're just sketching just this part of it, y equals x squared minus 1, we know this is a parabola. How do we know it's a parabola? Because of the x squared. X squared is always a parabola. All right, so now we're saying, well, if this is a parabola, can I manipulate it to make it look like the shifting format? Could we manipulate it to make it look like the shifting format? Yeah, so then we can shift it. Do you see this series of steps you should be asking yourself? All right, so let's sketch this. We're not concerned with the absolute value right now. We're not concerned with the absolute value right now. All right, so the am I shifting left or right at all? No. Am I shifting up or down at all? Yes. So here's my turning point. Will there be x-intercepts? It's smiling, right? It's smiling. So will there be x-intercepts? Yes. Do I need to find those x-intercepts? Yes. So we can't draw this until we find those x-intercepts. So the x-intercept is going to be 0 equals x squared minus 1. So what are my x-intercepts? Plus minus 1. We already know our y-intercept, right? You're going to miss something important. Okay. So now, this was just the sketch of x squared minus 1, but what do we have to do now? What must we do? we need to now take the absolute value of it. Remember, it was y equals the absolute value of x squared minus 1. So what does that mean? I need all my y values to be positive, so everything underneath the x-axis must be turned positive. What's my only point underneath the x-axis? -1. I'm going to now turn that positive. How do I turn that -1 positive? Make it a +1. So this point is going to get basically like reflected to up here. So what ends up happening? I am now, yes, you're going down to your x-intercept. You can't go past it, right? Because we're positive. Y has to be positive. So what happens? You bounce back up, and then you go back down to hit your other x-intercept, but then you can't go through it, so you have to go back up. So it looks like a W. Mm-hmm. Ariana?
Which is the y-intercept from the first place?
Oh, so when we were, guys, be quiet. When we were sketching, did you understand how we converted this into that? Like how we took this and converted it into that to make it the shifting? All right, so our parent graph looks like this with the vertex at 0, 0. But then what happened, based on our shifting, we're not shifting left or right at all, but we are shifting down 1. So I didn't actually have to plug in anything like algebraically because I knew I was shifting down 1. That was my y-intercept. All right, I'm going to give you one to do by yourself, then we'll be done, okay? All right, Dravid, is this a V?
Is this a V?
No, it's an x squared. Oh, she was asking
I said, when I preference something Dravid, how come it's not a V, Dravid?
Well, x squared.
All right, it's an x squared. What does a V look like? A V looks like something like that. Okay, so how do I know this is not a V? Because a V is not supposed to have an x squared. Just like a shooting star is not supposed to have an x squared. So this has an x squared, which means this is now like a special scenario where I have to approach things differently. Okay?
Wait, but what's the difference between this one and the one we just did?
It's negative.
It's very similar to the one we just did. You're going to follow that same approach to the one we just did.
Isn't it just upside down?
Oh,
Yeah.
Are we ready for this? All right, real quick before the bell rings, I don't think I'll have enough time, but what's going to happen is you are going to sketch x squared minus 1, which we already did. Didn't we already do that? Then what do? After we sketch that, we take absolute value. So how do we take the absolute value? We just take that part that's underneath and reflect it out. We'll get there. Ugh. All right, so it looks like this, right? But then what happened? Now they're saying the negation of this, right? So now we're saying the opposite of this. What did we mean? What did we say when there was a negative in front? Up or down, we reflect it, right? So now we're going to reflect this down. So we're going to create that W and make it look like an M. So we're going back down here. We're hitting all the same points now, but just reflected down. That's how that looks. All right, we are done. There's still another part of this lesson I didn't show you. No, we can do some of the homework. So I will tell you the homework that you can do. You can do half the homework. It's a worksheet. Was it not, was it